I want to find my purpose in life in this world. And I really thought that it came down to doing something that I felt really mattered. And that was right around the time that we started seeing hints that this is something much bigger than just a new toy. This was something about how I can actually structure computation, how I can even redefine the purpose of what a computer is. True entrepreneurs and founders is, entrepreneurs and founders are zealots. They care about something to an irrational extent. I will admit this freely. It was a fear-based decision. I was scared of what the future was going to bring and all the risks, because when you're doing it, everything that can go wrong. It hurts. It felt like I got dumped by my girlfriend or something. It was like this weird feeling. I was very upset about it. We got acquired and we were essentially put on a hiring freeze. It was one of the most ridiculous things I'd ever seen in my life. If you look at Moore's law as an economic law, that's kind of broken now, right? We're not seeing that anymore. We're working with Stanford on training a large-scale neural network, a GPT-style model. And after that, we can get the neural network to take the human physician licensing exam, the board exam called the USMLE. And we can actually assess its performance. It's pretty good. There's going to be this thing where I generate stuff for various industries, and it's completely open and untapped. Building these sort of synthetic intelligences that are capable of processing vast amounts of data, much more than any single human can process, is how we're going to make future scientific breakthroughs.
Naveen, you've been always fascinated by the idea of making machines more intelligent. So you've got your Ph.D. in computational neuroscience. You went and built Nervana that created the first AI chip. Then you led Intel AI, and now you're building Mosaic. I'd love to talk about Mosaic in a minute, but before we do that, I'd love to dive into the journey that got you here, starting with the early days with your work at hardware companies. So why hardware?
Yeah, I think and it's a great question. It was really that came from several sources. I, as an undergrad, was in a computational biology course, and there were a couple of facts I learned there that were just completely mind blowing to me. That I actually think set the stage here. One was that the retina, as it's made or grown or whatever you want to call it, actually does a real-time Laplacian. This is a mathematical transform where you basically find edges of things, and it was just mind-blowing to me that evolution could come up with such a complex mathematical transformation. It was like, wow, that's amazing that evolution, this undirected process, actually comes up with that. The second one was that the human brain runs on about 20 watts of energy, and that's somewhere around what your laptop uses. And those two things combined made it very clear to me that we're not doing it right in the synthetic world. And actually, that had nothing to do with my interest in hardware design. I think they were somewhat orthogonal. I was a computer science and electrical engineering major in undergrad, and I always loved to build things and program them and make them work. I did that even before I was in college, so it was just something I've always loved to do. And so combining those two things, it was just a very clear path for me from designing chips in industry, understanding more about the brain through my PhD, and then combining those two things to actually potentially make computers intelligent. That was the promise. That was the hope that I've always had for my entire life. It's like at the end of it, I want to look back and say, like, I helped make this happen.
I wonder, those early days of hardware, how did it change since then? How the way we approach it changed?
Yeah, I mean, it's interesting because our capabilities and our ability to think about a problem actually change with what tools we have available to us. That's been a constant throughout history. My advisor, my PhD advisor, would actually say, like, we always interpret a metaphor, or we always have a metaphor for the brain that's relevant to the current technology. In the 50s or even earlier, they would talk about the brain being a switchboard. Switchboard was how we connected phone calls, right? And now we talk about it being a computer. I think several things happened that got us to where we are now. I mean, Moore's law is a big part of this. Being able to jam more transistors on on a unit area of silicon actually means a lot. It allows us to have a certain density of computation within a certain power envelope and within a certain physical space that got to a critical point where all of a sudden we could actually start processing large enough amounts of data to start using these paradigms like neural networks. We could start seeing things that are kind of infinite variance distributions instead of like, kind of finite known type variance distributions. And I think that was a big inflection point that probably happened, in the mid to late 2000s, really. And, it started manifesting itself through ImageNet and things like that. But, the GPU architecture was part of that trend. High degrees of parallelism enabled neural network computations to work. And, this is where hardware design allowed new algorithms to work, kind of gave rise to new hardware, except it keeps going like this. So this latter effect is actually something we've observed in many places. And I think that's what made it very exciting for me to actually go and say, oh, now we know what to build in hardware, let's build it. And that's going to enable a whole new set of explorations that we can't even think about right now.
Right, and this is like a virtual cycle where new hardware enables new software, and then we use that new software to design the ever more powerful hardware.
Exactly.
You mentioned that our brain works on 20 watt of energy, and we're not there yet with the hardware. Do you have any ideas or any thoughts on why it's not there and what it will take us to get there?
Yeah, actually, there's several things. What's really interesting is if you look at, I'd say the smallest elements of computation in a silicon design, which would be a transistor or a gate. A gate is approximately 3 or 4 transistors, so they're almost one and the same. And the smallest unit of computation in the brain is, you could call it a neuron or maybe a synapse. So if you take those two things, the transistor is actually quite efficient. It's a very good device. It does lots of things better than a neuron, and is actually extremely small now. So at the fundamental level, I think we actually have a pretty decent substrate. So everything above that, everything on how we organize transistors is in the realm of either circuit design or computer architecture. So I actually think the problem has now moved to how we architect data flow, how we organize the movement of information to actually learn from that information. That's actually more of an algorithmic thing than it is a device physics thing, in my view. So I think we've actually now moved beyond the realm of just thinking about the device physics. That 20 watts is going to come about through much better circuit design, things like analog compute and other things. But I think the transistor itself is a good fundamental building block. It's also going to come about from new kinds of parallelisms and ways of utilizing energy most effectively on the chip. So this is actually more of an algorithmic thing, and I think that was actually one of the big motivators for me to start Mosaic ML. Was I think the problem space has now shifted into how can we organize information flow better rather than how can I build a better computer architecture. We did that at Nervana. It was the right thing to do then. The world has sort of adopted that now, and there are lots of players building cool hardware. NVIDIA is a clear leader here, but there's a lot of innovation happening there. But now the problem space, at least the next problem space in my mind, has moved to how do we make the learning process more efficient.
Gotcha. And we'll talk about that in a minute. But before that, so you were in the business world, and then you moved back to academia to get your PhD. I wonder, what was your thinking process around that? Why break the career and go for PhD?
Well, you and my parents and lots of other people asked me that question as well. I had a great career as a manager, software engineer, hardware engineer in Silicon Valley, and really it came down to I want to find my purpose in life, in this world, and I really thought that it came down to doing something that I felt really mattered. I could keep making money, being comfortable, all of that stuff, in the current career, but it was now or never. I had 1.5 kids. It was a big leap of faith, really. And like I said, my family thought I was crazy. Lots of my friends thought I was crazy. But I did it because I really wanted to do it. And I actually quite loved grad school. You talk to a lot of grad students and they're like, oh, it was depressing and this and that. I loved it. I loved the ability to dive back in and just learn. I could talk to Nobel laureates about their work. I could do all of that stuff and attend lectures. For me, it was a lot of fun. I took the attitude of, I don't know anything. And I think that served me well there, because I was able to start leveraging my background more and more through time as I learned the basics. And, I think it was a lot of fun to just be thrown into something you don't know, and then starting to find your way, and then actually supercharging your learning capabilities by combining your background. And really, it turned out to be a good call in terms of time. That was right around the time that AI started becoming a thing again. So it actually worked out well. But, had it not worked out well from an industry standpoint, I think I still wouldn't have regretted this decision. It was just one of the most amazing times of life.
Do you think that difference in attitude between you and some other grad students, could it come from the fact that you didn't join it right after the college, but spent some years working?
Yeah, I think absolutely. I usually, if people ask me for advice on this, I generally tell them, go work for a little while before you get a PhD, especially in computer science or engineering. I think it's just so much more grounded in the reality and very attached to industry. But I came in with a focus, right? I didn't meander around. I think that meandering and uncertainty is what causes people stress many times. And I didn't have that. I came in and there was a specific set of things I wanted to understand. And, I used the opportunity to, learn as much as I possibly could. And so that just made it super fun.
It's a huge commitment. Was
It
it full
is.
time? How long did it take you to go through the whole course?
Yeah, it was full time, but I was in a startup before, which I didn't completely quit. I was actually working quarter time for a little while, so I was doing that on the side. That startup got acquired, and then I had the acquiring company didn't want to keep part time employees. So after about a year into grad school, I stopped. But I actually was very fast in grad school. I think I even set the record in my department, 3 years and 9 months. I finished my PhD, so which was, again, I think a testament to just how passionate I was about the space. Also, an interesting thing is, I had 2 small children as well, and that has a way of focusing you. You have I have 6 hours because I have somebody taking care of the kids right now, or whatever, and I have to make that 6 hours count. And so I think it ended up being almost good for me in terms of enforcing a discipline of when I studied and when I did my work. But yeah, I think a lot of it just came down to attitude of I wanted to do this. It wasn't forced upon me. I wanted it. And so, when you want something, that internal motivation is hard to beat.
Right. And necessity is mother of inventions. Having that
Absolutely.
need uh, to do it faster than many.
That's true.
Definitely
Yeah.
should focus. Cool. So your work, your PhD, did it have any influence on the next step found in Nervana?
Yeah, absolutely. It was one of these things, actually. When I started my PhD, my goal was always to bring back that knowledge into industry to make computers better. That was my entire goal. I even wrote this in my application. Interestingly, throughout my PhD, I kind of fell in love with research, and actually tried to have a go at making it work in academia. Academia is very hard, especially when you have a family and things like that. You get paid very, very little for a very long time, and so I just couldn't quite make it work. But yeah, I always had that goal of bringing it back. And so, once I finished, I mean, it was interesting because what it did is really change my perspective and open up new ways of thinking, how information is distributed in a system. These things weren't exploited well in computer architecture simply because I think it's just silos of information, right? Like computational neuroscientists think about information flow in the brain. They actually don't know much about computer architecture. And computer architecture architects don't really know much about brains, really, and distributed representations and all this kind of stuff. Both are very smart people and may discover some of those same concepts on their own. But I think just having the perspective of combining the two led to a lot of sort of breakthroughs in my own mind, at least, of, hey, we can think about this problem differently, right? We don't need to think about it in the strict serial pipeline way that we do in computer architecture. Now that's a foregone conclusion. Everything works like that. But at the time, it was still quite new. And I think that's what it allowed me to do, is just sort of open my aperture, on new ideas.
So how did you start working on Nervana? Was there some trigger, some event that led to that?
Yeah, I was actually a researcher at Qualcomm, corporate R&D, and working on neuromorphic architectures. So neuromorphic architectures are computing architectures that mimic some aspects of the brain. They use like spiking neural networks and this kind of thing. I was working on those things. I saw there's potential promise, but there's also a lot of pitfalls, which again, as a computer architect, I was kind of uniquely able to see. It's like, yeah, these things aren't going to work. It comes down to memory bandwidth and et cetera, et cetera. And that's when, from the academic world, I kept eyes on deep learning or neural network computation. And that was right around the time that we started seeing hints that this is something much bigger than just a new toy. This was something about how I can actually structure computation, how I can even redefine the purpose of what a computer is. A computer is no longer something that, runs web servers and runs Microsoft Word. It's actually something that can find, useful structure in data. And so from that, basically said, okay, well, if that's the purpose, if a computer's purpose is now to find useful structure in data, what would I build? I wouldn't build what we build now or back then. I would build something different. It would be a massively parallel distributed architecture. And so that was kind of the seed of it. I actually pitched this at Qualcomm. They didn't want to abandon the neuromorphic stuff and wanted to stay on track there. And I said, okay, that's fine. I started talking to external investors along with my co-founder, Amir Khosrowshahi. So when we talked to some investors, I said, okay, I'm in. So then I guess we were off to the races and we started the company.
Gotcha. This is quite a typical story. Intel, I believe, the guys also pitched it back then to their company and got rejected. Was at Apple. So it makes you wonder why those big corporations keep not learning the lesson of nurturing innovation in house.
It's hard, right? Because I saw this firsthand at Intel on the executive staff too. It's very hard to justify spend on something that one, could potentially disrupt your core product, and two, by their view, is not proven. So this is what's, I think, a really big difference between kind of professional managers and true entrepreneurs and founders is, entrepreneurs and founders are zealots. They care about something to an irrational extent. And when they care, when their view is correct, which it's not always perfect, but the high level stuff have to be correct, that's when new things happen, because you push on it and you make it happen. Inside of a big organization, an established organization, it's very hard to do that, because the job of professional managers is not to take risks. It's to deliver shareholder value, right? And many times that comes in increments, 10% per year or whatever, right? And so it doesn't come in paradigm shifts. And so there's actually an incentive not to be innovative in large organizations many times. And there's many books written on this, like The Innovator's Dilemma, these kind of things. And I've seen it happen in my career multiple times, and I've been like the victim of it a couple of times. But in the defense of the management, it's hard to make a call like that, right? It's very risky. All you have is potential downside, right? If you make the wrong call, you spent a bunch of money. Like you see it with Mark Zuckerberg right now. He's a zealot about the metaverse stuff, spending a lot of money. He's already getting pushback from his board and investors. So there's an incentive structure created to not necessarily go in these new directions.
This is a blessing and a danger of a founder-controlled company.
Yes,
Depending on the day, you would either condemn him or kind of say that he's genius.
that's
That
right.
was, I think, the case with Instagram as well. At the very early, like initially, it was a big question: why pay $1 billion for a few guys and a small iPhone app?
That's right.
And the truth is, no one knows. Not even Mark. Nobody has a crystal ball to tell whether that will pay off eventually.
Right.
You need to place your bet somewhere. And yeah, it's interesting that he has this opportunity, which is not necessarily what shareholders, as you said, expect from him.
That's right. I mean, he's now, running, one of the largest companies in the world, and the sort of risk averse investors come in now, right? Whereas venture investors are risk seeking many times, right? I think these days maybe not so much, but in the past they have been very risk seeking, and they want to find these like paradigm shifts because that's where the big returns come from. I mean, I would say a success story here is Jenson Huang of NVIDIA, right? He made that company into an AI company by his sheer will. It was a graphics company that wasn't doing very well. In 2010, I think they nearly died, right? Or nearly died multiple times. He had the wherewithal to keep investing in the directions he felt were important, like parallel computing and CUDA and all of that. And it turned out they found the application of AI. It kind of fell in their lap, but that came through a set of investments that they had made in this parallel computing, and they were the only game in town. And so that's where these workloads tend to land. And then they then executed like mad on it, right? And that's because of his focus. Had he not done that, if that company were run by a professional manager, NVIDIA would not be the leader of AI right now. I can guarantee you that.
Right. Yeah, that's actually a very good point. Now you've built Nirvana to a certain point. What was the level that you got it, and when you decided that it's the right call to partner with Intel?
Yeah, that's always a tough one. We raised $24 million. We were a very efficiently run company. We actually had revenues through our service, actually run on NVIDIA GPUs of all things. But then we were basically going to replace that with our own silicon, very similar to what Google did with TPUs later on. So that was our strategy. We had a few million in revenue at the point, but this was 2016, and we had been on a bull run in the markets since 2011. I still carry the scars from 2000 with the dot-com bubble and all that stuff. And I was like, man, something's going to happen, right? What's our forward adjusted risk, payout and all that kind of stuff. And so I made the call to sell to Intel when the offer came in. Some folks on the board didn't want to sell. They didn't want to fight me on it, but they didn't want to sell because they thought we had a bigger opportunity. I think they were right in the end, honestly, because we had timed it perfectly. We could have been a true competitor to NVIDIA and others at that point because we hit the market timing right. But it's very hard to know these things. And I will say, I will admit this freely, it was a fear-based decision. I was scared of what the future was going to bring and all the risks, because when you're doing it, everything that can go wrong, right? At that point, I wrote the initial device drivers and stuff like that. I was actually writing code still at that point, and I was just scared of the whole thing, and I bet my whole family on this. I don't think people understand the risks that entrepreneurs take. Like, if Nervana didn't work out well, like, I mortgaged my kids' future on this. It's quite stressful, right? And when the offer comes in, it's like all you got to do is sign, and all the pain goes away. And that was the fear, right? And I think that was what probably drove me to make the decision in the end. It was good enough. My investors were happy with the return. We come out on top. It looks good, but it was too early in retrospect.
2016
Yeah.
was still before those mega rounds
Yes.
of VCs, those huge checks that AI commands these days, and also before, I think, those huge cash out deals for entrepreneurs when you can sell some of your stock during the rounds
That's right.
and get tens of millions of dollars to make sure you're not worried about that part of mortgaging your family, as you said.
That's right. It's interesting. Matt Ocko from DCVC was on my board. He didn't want to sell, and he actually, and this is something that I will never forget. He was basically like, "Look, we don't want to sell because we think this is going to be way bigger." He's like, "I'll write you a check for $1 million right now, personally, to make this go away." So it was one of these things. Like I was like, "Man, that's having your back, right?" And people like that I will always work with again. And Matt is actually in Mosaic as well for that reason. Having investors that have your back is super important, that understand your vision and support your vision. But yeah, it was fear based. What drove the decision in the end was fear of the unknown.
You said you had scars from 2000 bubble. What were those scars?
Yeah, I've been in startups for a long time. I dropped out of Stanford in the late '90s and went to a startup. I was in a startup that was actually doing very well in it was actually long range wireless communication. This is before there was Wi-Fi. This is before there was really cellular data or even fiber to the curb. And we had a great technology that was working. We had 18 months of runway of money in the bank, and through fear of recession and all of that, our investors. This is right after the stock market tanked. Our investors actually pulled the money out, and the whole company went under, like in a moment's notice. It was very sad. That was a company that I put my heart and soul into. Like I felt a lot of personal ownership. I was there for about 3 years, and yeah, it was like it hurt. It felt like I got dumped by my girlfriend or something. It was like this weird feeling. I was very upset about it, um, and so that was. It's one of these things as a young engineer. When that stuff happens to you, it leaves a mark, right? You remember those times, and it's actually very similar to this moment right now. Companies were lavishly spending in 1999. I remember some startup who raised money, had Aerosmith at their Christmas party, and then the next year when everything tanked, there were what they called pink slip parties where people would go and say like, I got my company went under, or I got laid off, and they were all trying to find jobs, right? It's very similar to right now. In fact, in 2021 is kind of analogous to 1999. So those are lessons. They're things that I think that scar actually helps you sometimes. I saw similar patterns last year in our current markets, and actually acted a little bit accordingly. I didn't try to scale up too fast, hyper growth, blah blah blah. I didn't do that stuff with Nervana or with Mosaic, and I think that served us well in the current environment.
Yeah, the history does rhyme. You would think we learned our lessons in 2000, but
Well,
it seems new generation
new generation.
of people.
That's right. No, totally. It's interesting because we've been on that bull run since 2011. So there are people that have more than 10 years of experience. These are not like new college grads. 10 years of experience who've never seen a downturn. They've only saw things go up. And when that happens, right, you don't think about the downturn, right? You've never seen it. It's a theoretical thing. It's not going to happen, right? Until it does.
Yeah, that's the only thing they might have seen in their whole career after finishing
That's
college.
right.
So it's not only the 10 years; it's also like the only 10 years they ever had.
Exactly.
Okay, so let's talk about Intel AI. What was that? You built it from scratch. So what was your vision for it, and did it go as you planned?
Well, so the short answer, did it go as I planned? Not exactly. I think some aspects did, but not precisely. When the whole thesis behind getting acquired by Intel was that we had the best computing architecture for neural networks at the time. It was, basically a tensor architecture, 2D math kind of a thing, which is what GPUs are now. At the time, GPUs were not that. CPUs were definitely not that. There was no, really mainstream computing architecture that did that. DSPs, maybe a little bit. So we basically said, if we can get the best architecture on the best silicon process node, which Intel purportedly had at that time, we would be unstoppable. And that was really the goal, was let's get the best process combined with this. And when I came into the company, it was interesting. This was right after a large round of layoffs. I think there were 10, 15,000 people laid off Intel in mid 2016. We got acquired in August of 2016. That created this conservatism again. People who are professional managers, they've got to return shareholder value. That's what they're thinking about. And we got acquired, and we were essentially put on a hiring freeze. It was one of the most ridiculous things I'd ever seen in my life. I was just like, you paid $400 million for this company, and you put us under a hiring freeze. So we really couldn't even do much. And our team at first, they were energized. They're like, okay, we're going to get all these resources. We're going to go build this thing. Our vision is going to come to fruition. We came in, and it was just like, we're on pause. So that went on for a while, almost a year. It wasn't actually until summer of 2017 that we started the Intel AI group properly. It was called AI Products Group, or AIPG, inside of Intel. And at that point, before that, the CEO, Brian Krzanich, was discussing what we should do going forward. And then eventually he came to the conclusion that we needed to start a new group, and he asked me to run it. I'd never really taken on such a large undertaking in a big company like that. And really what was tough was my mandate was to look around the whole company, find projects that are AI related, bring them under one umbrella, rationalize them into one set of products. This is really hard in a big company. There's so many politics. There's so many, groups all over the place. They're in different, geographic areas all over the world. It was quite tough. And, that was not something that sped us up, probably slowed us down in retrospect. But the vision that I presented to the board at that time was really about combining the CPU, the ability to program x86 with C++ code with tensor computing. Put those two things together, along with very high bandwidth chip-to-chip I/O, and build this substrate that whose interface is basically standard x86. That was the goal, and we're actually starting to see some of those things happen now, but it's years. It took a lot longer than we expected. We went through the course of like saying, okay, well, we're just going to build discrete products like the Nervana training chip and inference, and then also the Movidius chip, all of these things, rather than combining them. It was just too hard for lots of political and other reasons within the company. Also turned out that the process node from Intel was no longer state of the art. Maybe you heard of that. We didn't know that at the beginning, or I didn't know it at the beginning. I think some people inside did. So that changed our entire course, right? We actually were going to build the Nervana chips on Intel, and then we started to discover this isn't going to happen. We had to stop, restart, and build it on TSMC. Intel didn't have good resources to build on TSMC. I mean, they had some, but not enough for us to do it. We had to go find contract shops to do it. It was one of these things, like every assumption we had kept breaking, which again is not so atypical for new products. I think that's just kind of how products happen. Like, you make assumptions, they're not always right. But the process was messy, a lot messier than we anticipated. We did end up building the products. They were highly performant. We then even shipped them to some large tech companies that I can't really talk about. But it did end up working in the end, but it's a lot messier than it should have been.
And did it slow you down so significantly that the window was kind of passed already and captured by NVIDIA? Everyone standardized on it by that time?
Yeah, pretty much. I feared this when I came in because I knew it, right? I saw that we had a lead, right? Because we had this tensor architecture. Um, what NVIDIA did, this is what Jenson, I have a lot of respect for what Jenson did here. When we got acquired, when Nervana was acquired by Intel, Jensen still thinks like a founder, right? He was like, oh shit, they're going to kill us. So he forced his team to execute like mad and get the V100 announced in May of 2017. So like 7 months, 8 months after we were acquired, he announced the tensor architecture and shipped it in 2017, like end of 2017. That's an incredibly fast turnaround time for such a large architectural change. So kudos to them for executing well. We meanwhile we're under a hiring freeze, right? So our window was slipping away day by day, and honestly, I knew it. I pounded my fist on the table. I said it. It's hard to get people to listen because it's like kind of a theoretical. It's like, no, I'm telling you, this is happening right now. You need to invest and go. But it's hard to convince people, especially when CPU sales were still very good, right? They were still growing. It was Intel owned the data center still at that point. So it's very difficult to convince people that, hey, this impending doom is coming. I'm trying to warn you. So yeah. Anyway, that's just kind of the dynamics that happen in a big company.
It's interesting that the acquisition actually served as a trigger to speed up or shake up NVIDIA and make them
Yeah.
move faster. So you played a
Yeah.
role in getting the V100 maybe sooner than it would have been otherwise, and speeding up the whole evolution of AI in that indirect way, I guess.
That's right. Yeah. Exactly.
Do you think, in terms of the state of the art chip production, do you think it's a question of scale that TSMC managed to become the leader there? And uh, we are aware of Intel kind of struggle there, or at least
Yeah.
like some struggles that they had in the past. Is it the pure scale question?
It's scale and diversity of products. So there's a few reasons. I actually, Intel did have problems on execution, but they still have amazing engineers on the process side, no doubt about it. I think what happened was they tried to reach too far and couldn't hit it, whereas TSMC took a much more incremental approach. And they did that because they have many different types of products running on their fabs, right? They had mobile, they had data center, they had high density logic like GPUs, they had some memory, they had high clock rate logic like CPUs, they had all kinds of different stuff. That diversity allows them to take a different view on economics. One is that they can amortize their investment in new stuff across many different sectors. The other part is that because they're actually even fabbing older stuff that don't need the latest greatest process node, they can actually keep the equipment that was built for the old process node running for longer. They can amortize their past investments for much longer than Intel. If you look at the lifetime of a process node at TSMC, it ramps up, you get latest greatest stuff, and then it has this long tail for 5, 7, 8 years of revenue after the initial investment. Intel, because they primarily fabricated CPUs, they'll ramp up the new process node, get the latest stuff out there, and then their next CPU has to be on the latest again. So they ramp down the old process, and so they can't amortize the equipment for as long of a period. So that hurt Intel quite a lot. And you're right, the scale is a part of that. At some point, the scale of TSMC just made it so much harder to compete than with Intel. Also, getting on the state-of-the-art process node has become increasingly expensive. It's sort of the inverse part of Moore's law is that going from 28 nanometer to 16 nanometer cost X, going from 16 nanometer to 7 nanometer cost 4X, right? And so every new generation ended up costing so much more, and at some point there wasn't enough scale at Intel to justify it. There are also other things in the way the complexity of the CPU kind of evolved over time. And basically, they lost their advantage of having the fab in house combined with the logic design. That model didn't pan out new performance anymore, or better performance. And so I think there's a lot of different reasons why this happened. But again, when we came into Intel, we didn't know this, and I think it was the beginning of 2018. I was in the war room. I saw it. Everyone's like, "Wow, okay, we need to fix something here." I was in lots of executive meetings around this, and I had no idea what the extent was until 2018. There were a lot of problems and a lot of things that didn't work that people said were going to work. They had faith that it would work.
Right. Sometimes the faith can be very misleading. But it looks like
Yeah.
from what you told that as we go smaller and smaller node size, we need more and more investments. So it makes economical sense to have fewer and fewer uh, fabs out there. So if we could afford uh, 10 different fabs for a bigger node, now for a tiny nodes, we only can afford to have maybe or justify economically without subsidies to have only a few out there. And the question is where those few will be located, and there is
Well, yeah,
no way around it. So the next couple generations will be so expensive, it seems, that only one fab in the world economically will be able to afford it, or we will have to live with the idea that we always need to subsidize it uh, locally because we just want it to be local for some other reasons.
that's right. Yeah, I mean, geopolitical reasons, of course, right now. I mean, I still think there is competition, but you're right. It's kind of fallen into two or three players. There are really three players for the state of the art fabbing right now. It's Intel, TSMC, and Samsung. Um, I think that's going to stay stable for a little while. There seems to be enough of a market to justify that, even without government subsidies. Even though we are doing that for geopolitical reasons right now. I do think Intel has made the right move to focus on fabbing external people's chips. Honestly, I don't think the company went far enough. I was actually very hopeful that with a new leader who came in, that they would split the company, because the fab has to kind of live on its own. It has to survive on its own with its own competitors, right? Like TSMC. Having that, kind of guaranteed volume from the CPU is just hurting it. It's like a handout or something for the fab, And I think it would be better if it was just spun out. That's my own personal view. But yeah, I don't know. They have made the right move to focus on that, though, and so I'm hopeful. I want Intel to succeed because they need to succeed for the Western world, right? We need that competition. We need those capabilities here. It's important for us.
Okay, so you spent several years at Intel, and then you decided to found Mosaic. Uh, why focus on efficiency right now?
Yeah, I mean, part of it is Moore's law. If you look at the latest NVIDIA chip, the H100 they just announced, right, and compare it to the A100, the previous generation, it's the new process node. It basically uses 2x the power and has 2x the performance, and it costs 2x the price. So if you look at Moore's law as an economic law, where you get the same performance for half the price, or get 2x the performance for the same price, however you want to look at it, that's kind of broken now, right? We're not seeing that anymore. They're still doing innovations on architecture and stuff like that they're getting performance that way, but not from the transistors anymore. So because of that, we need another way to find performance and stabilize costs. So one of the founding motivations for Mosaic was, is there somewhere else in the sum we can look to make each computing flop more effective and efficient for learning from data? That was the goal. And it wasn't, you can do it through software. You can optimize software, and you'll get 5%, 10% maybe per year. But you don't get what the demand is. The demand here is actually more like 400%, 500% per year. That's what the state of the art is moving at. So if the state of the art is moving 4x, 5x per year, and you're only delivering 40% per year, you're always just going to have this, spiraling cost. And so we saw that happening. Training large scale neural networks like GPT-3 costs $5 to $10 million, right? This was not something that anyone else can do. And I don't like a world where there's one model owned by two tech companies or something, right? That is a recipe for disaster, in my view. Even though those tech companies want to do that, that's what they want that worldview to be. I don't think that's how innovation and proliferation of technology happens. So how can we change that? Well, can we bring the cost down? Can we make it tractable, something in the $500,000 range? Can we make it easy to use? Right now, or at that time, you needed a team of experts who knew how to do these, massive parallelization frameworks. Can we make all of that easy to use? And so that was really the founding thesis of Mosaic, and we've done that with GPT-3. We can train it for $450,000, and that's a real number that has margin in it for us, for every provider that provides different parts of the tooling. That's a real market number. We have also made it very easy to use by basically making it an API. You can just call an API and say how many GPUs you want it to use, 8 or 8,000. We don't care. We've made it completely scalable. So that's going to have the effect of making these capabilities accessible by many different industries, allowing each of those industries to actually build their own models and build them on their own data for their own purposes. And there's a lot of reasons that makes a lot of sense.
So how does the system work from the customer perspective? You said it's a set of APIs. Say I lead a team, ML engineering team at a large organization. We want to train our own either GPT-3 version or maybe image generation model. So what are the steps we take, and what are the most important things we should keep in mind to take the most or to get the most from your system?
Yeah, so steps are pretty easy. We have a pretty straightforward onboarding process. There's a few different ways we sell. One is that we actually have a fully managed service where we work with a cloud provider and actually allocate compute up front. So we do that work, and then we basically sell it all together as an API with a fully managed service. The other one is, some companies have allocations of GPUs in various clouds, AWS, Azure, GCP, Oracle, whatever. We can then manage those GPUs on behalf of the user. And basically all they do is decide what their data sources are. So clean those data sources are, put them into an object store of some sort. It can be anywhere, S3, GCP, GCS, whatever. Set up the certificates so that they connect those data sources to our service, and then say, train this model. It's pretty much that simple, and do it on whatever number of GPUs that they have available. So it's a very straightforward usage. And what's interesting here is that from an industry perspective, we see industries now being able to hire machine learning teams. 5 years ago, they couldn't. All of those machine learning engineers went to Google or Microsoft or wherever. Now, different industries are able to hire a team. And these teams aren't huge. They're like 10, 20 people, 30 people maybe. But they understand what they want to do with data. They understand something about models. They know what BERT is or GPT or whatever, and they know what model they want to use. Now, what we do is enable that team to be superstars. They can basically have similar capabilities to what you have inside of Google or OpenAI or whatever, and be able to run their models on their data within their organizations.
How does the system work under the hood? What are the most important breakthroughs that you discovered during the building the system?
Yeah, there are two aspects to it. So they address two needs in the market. So accessibility has two major components. One is cost, and one is ease of use. So for the ease of use side, we built very resilient and robust set of tools that go and do all the orchestration under the hood, basically spin up all the instances you need, put down the right Dockers that have all the right software on it, coordinate them to work together, run your job, write everything into object store, deal with node failures. GPU nodes fail all the time. Being able to deal with that gracefully, dealing with things like loss spikes and stuff like that gracefully. That's all on the orchestration tooling side. That addresses the ease of use problem. On the cost problem, this is where some of our deep tech is. One of the first people at Mosaic is Jonathan Frankel, who published a paper called the lottery ticket hypothesis. This is a foundational paper in what we call compute efficient learning. And what we found is that there are multiple different techniques you have to combine, and you can actually make a neural network learn from data more efficiently. We've actually shown this in ML Perf. This is an industry benchmark for training neural networks, showcasing hardware, that kind of a thing. We actually won the ImageNet benchmark about 5 months ago, and just yesterday or day before yesterday, the results were released for BERT, the natural language processing benchmark, and we won that as well. We're about half the time of anybody else on existing hardware. So how do we do that? Well, it comes down to lots of clever engineering around how data is presented to the neural network. When a neural network's learning at the beginning, it learns very gross features. It doesn't need fine features. So you can actually present to it gross data points and it learns those features. Then you can present the more fine features. It's like a baby, right? When you teach a baby, you don't teach a baby calculus. First, you talk about counting. So we do something similar, and actually that saves a lot of computing flops doing that. Other things like learning rate and regularization techniques allow us to be much more efficient with flops and data. And finally, we actually write some low-level software to make things more efficient as well. This is just understanding where the bottlenecks are in the system and addressing those through software.
How do you approach the most recent efficiency-focused technologies or ideas in the community, like using like transfer learning, like active learning?
Yeah, I mean, we work within that community, right? In fact, our a lot of our implementations are open source. They're in an open source library called Composer. If you look at Mosaic ML Composer, you can see it. So we have about 20 or 30 methods, I think, in that library that you can play with. We are actually getting contributions from the community as well. So we are completely hooked into that. We actually have one researcher who literally reads every paper that's put on archive, not every the full paper, but the summaries of them every week, and actually has a newsletter around this. And so this allows us to stay on top of what the latest stuff is. Now, in terms of transfer learning, this is an interesting one. When you're talking about classification performance, stuff like that, transfer learning is great. It can do it can jumpstart where your starting point for training and reduce flops quite a lot. When you start working with generative models, these things are a little bit more difficult. We call them pre-training and fine-tuning typically. When you deal with a generative model, it can actually memorize portions of the training's data set. We've seen this with Copilot already, is that it can memorize pieces of code that it was trained upon, and when it's prompted the right way, will actually spit that back out. And this is like a human does this too, right? We spit out things that we've learned over our lifetime. But the implications are that if you take something that is trained on apocryphal data sources, you don't know where the data came from, you might have information in your neural network that you don't want. You might have information in your neural network that has not been permissioned for use. This actually is a huge barrier for enterprise companies, for governments, for really serious industries. They need to know what's inside their neural network. Neural networks are no longer just this, transformation of input pixels or features. It's actually like it becomes almost like a database that holds information in a new format. So transfer learning, it needs to be used very judiciously. You need to know what you're doing. And I actually think this is one of the main reasons that enterprises need to train their own models. They need to understand where the data came from.
Is it efficient for each enterprise to train the model, assuming that you definitely don't want the uh, unwanted data in it,
Right.
but probably most of them will want the same set of clear, clean baseline data. So would it make sense to have someone train that model first on that baseline set and then them work on fine tuning it?
In some cases, sure. What we see also, though, is these companies that are building these mega models, that are enormous. It does lots of things, and it does them sort of well, but it's not a domain expert. If you want to build something that's made for processing legal jargon, you need to train on legal jargon, right? That's just intuitive, right? If you want to be a professional violinist, you need to play the violin, right? You can't play the piano and expect that to transfer to a point where you are competitive with someone who's played the violin since they were 3. So it's the same idea here: is that you need to train on the domain specific data. And what's a knock-on effect here is that you can actually get away with smaller neural networks. You don't need these enormous neural networks that are very unwieldy. Large neural networks are expensive to do inference on. If you're trying to do inference on GPT-3, it costs a lot of money and is very slow, just because there's a ton of computation involved. So instead of like taking one model and trying to train it with everything under the sun, one, you'll get worse performance, but two, you can make a smaller model that's actually very tailor fit to your needs. And I think this is what we're seeing now, is that companies are kind of tired of using these, gigantic models. I mean, bless all the companies that have put the investment in to build these big models, because they've shown what's possible. I love it, right? GPT-3 from OpenAI, Lambda from Google. I mean, they put a ton of money into these things. They showed what can really happen when you engineer the system right. But I don't think it actually hits the mark when it comes to what industry needs. They need to be able to build their own models on their own data, and focus those models on the use cases they care about, because then you get something that's much more, much cheaper and easier to serve.
Right. It's like building supercomputers to show what you can do with the compute, but then turns out everyone wants a smartphone with a
Exactly. Yeah.
much smaller compute power, but other things beat, like mobility, beat the power every day. So, what are your favorite examples of using Mosaic in the real world? You mentioned GPT-3, you mentioned ML competition, and I'll make sure we link those things to the show notes. What are the other interesting things?
Yeah, there's one that's not quite published yet. We'll be getting it out soon, but we're working with Stanford on training um, a large scale neural network, a GPT style model, on a bunch of biomedical data or literature like PubMed. And after that, we can get the neural network to take the human physician licensing exam, the board exam called the USMLE, and we can actually assess its performance. It's pretty good. So this is a really neat demonstration of what's possible when you build domain specificity. This is not a huge model. I'm going to save some of the details for the publishing, but it's not a huge model. It's much smaller. It's much cheaper to both train and do inference on, but it gets very good performance on this particular task. And if that's your task, then that's what you care about. So we'll be making that available soon, and you'll be able to play with it as well. I think that's just a great demo of the power of training your own models on your own data. You get something that performs way better on those specific tasks. And in the end, right, that's what you care about. It's very similar to how robotics works, right? You can make some, perfect humanoid, but that might take $1 trillion to build. Or you can make robots that solve a problem today, right?
Right. This is what people in robotics now talking about: a single purpose robot that
Yeah,
does a narrow function but does it really well, is cheap and easy to install and use.
exactly.
And that the model that you're talking about sounds very impressive. The models, all of them, all of the neural network based models have this issue with probabilistic responses and
Yeah.
with biases and with just being wrong randomly and unpredictably. So how do you compensate for that?
That's a great question, and it is definitely a problem, but that's something we're all working on as a field. Um, they're not biased per se; they're biased because the data they're trained on. So I think data engineering is going to be a big part of this. Some sort of um, testing evaluation frameworks are also going to be important. If you think about it, a human is no different. A human learns stuff. We have priors from our childhood that bias us in different directions. But we standardize behavior to some degree. If you're going to be a surgeon, you have to go through extensive training and testing, right? And then eventually we have certain gates you've jumped through that say, okay, we trust that your output is going to be good. Same thing is true for driving a car, right? You kind of assume that someone can drive when we do some basic tests and that kind of a thing. So I think we do this already with humans. We got to come up with these kind of evaluation frameworks for neural networks. It's going to be very difficult to engineer them to always perfectly give the right answer, but I think that's true with any sufficiently complex system, um, including a human or an animal. Like, I mean, animals are trained and they work most of the time, but sometimes they kill people, right? It does happen, and I think that's a similar idea here. Is that we want to minimize that and come up with ways that either we can do redundancy checking between two different ways of computing answers, and then if there's disagreement, we don't use that answer or something like that. Evaluation, making them pass a test before they can be deployed in the real world. There's a lot of solutions to this, and I think as an industry, we're going to figure that problem out. It is a problem, though. I 100% agree.
Yeah, you're right. And this, when talking about that, where humans are the same way, the thing is, we kind of got used to us being somewhat imperfect, and yeah, we always hope that technology will compensate for that imperfection. And then when we see it in technology, we freak out. Although you're right that this progress in machine learning, this understanding of it, everyone who dives deep into it, I think, gets a new perspective on human mind and on
Yeah,
our own shortcomings. So that's, even for only that reason, it's a very good idea to uh, dive deep into machine learning models and modern machine learning models to better understand humans.
absolutely. Yeah,
Okay, let's talk about the team at Mosaic. You're partnered with Hanlin Tang as your co-founder to
yeah,
build the company. Hanlin joined Nervana, I believe, about several months before the acquisition, and then worked with you at Intel.
that's right.
So I'm curious, what is your approach, and what would you say? Like, how do you think about partnering with someone to be your co-founder?
Yeah, I mean it's a big decision, right? Because you're going to be spending a lot of time with that person. It's almost like it's a very intimate interaction in some ways, right? You go through the whole range of emotions, all your fears, your doubts, your happiness, all of that. And so I think it's an important decision to make. I mean, one of them is that you want you want to work with people that you trust their judgment, just implicitly. You trust that they have done the best solution that anyone can do, and I think that's important for me. The idea of like utter competence, you can't find anything wrong ever, and even your first employees that you bring on should fall into that category. But things like that, right? Like, and being able to adapt to new situations. I mean, Hanlon is quite amazing at this. when he came to Nervana, he was basically able to do anything extremely well, And I think to me, it was like, I definitely want to work with this guy again. Like, he's amazing from that perspective. So, and of course, there's going to be hard times, and you've got to be able to work hard and work through them, right? You've got to grind sometimes, and you want that characteristic in your co-founders as well. So I think these are the decisions. It's an emotional decision, right? It's a feeling like, is this the right person to do this with? Do I want to be in the foxhole with this person?
Yeah, exactly. How did you go about like settling on, yeah, we're going to start the company?
Yeah, I think it's actually kind of a funny story. We started talking the summer of 2020. So I quit Intel in March of 2020, and started thinking about this problem and several other problems, to be honest. And just reading literature. I wasn't working, and I had some board duties and things like that. But I had a fair bit more time. Also, it was COVID. Everyone's sitting at home under lockdown. And I actually cold emailed Jonathan and his advisor, Mike Carbon, and said, "Hey, your paper's really cool. I think there's some potential, interest that we could potential interest from investors on building something around this." And so we just started talking on a weekly basis, and then we brought Hanlon in as well. But really, the idea was, can we think through, is there a way to innovate on algorithms to make learning more efficient? And after several months, we kind of came to the conclusion, yeah, I think it is. We really hadn't gotten to the point where we're like, okay, now we know how to do it. These are the things we're going to work on, and this is the business model. I actually didn't get to that point. I started talking to Shaheen Farshchi, who is a partner at Lux Capital. He's also a friend of mine, and we were talking about personal stuff, just catching up. And he's like, what are you doing these days? I'm like, I'm not doing anything. I'm just thinking about this problem. And then to him, he was like, light bulb. He's like, I'll just write you a term sheet. And I said, okay, hang on. I don't have a business plan. I got nothing. I got no deck, nothing, right? And he's like, no, don't worry about it. It's fine. We're going to bet on you again, because they were in Nervana as well. And I had also been working with DCBC on helping them with due diligence and things. And so I brought them in as well. Also, Steve Jurvetson, a friend of mine and someone who I worked with at Nervana as well. He led my Series A at Nervana. So I brought all these folks back because there was a lot of inherent trust between all of us. And then they wrote the term sheet, and we're like, okay, well, I guess I got to get a bank account. I got to start the company. And so we got it off the ground in January of 2021.
You almost started the company without a proper starting company.
Yeah. I mean, I had an idea. Like, I knew that we were going to be in the computing stack. I knew we can do this cross cloud, but we had to think through business model. And of course, we keep doing that, right? I mean, this is a constant process. Like, it's not. I feel like there's a lot of new founders like, oh, once I've achieved product market fit, I'm done. Like, no. There is no thing as achieving this one singular moment. It's a constant thing. You're always trying to fit your customers better and fit the market better. And that's still going now. We do have customers now working and doing really cool things. We do have a way we think about the business. The way we do pricing and stuff like that is always being tweaked right now. But I think we had to put all that together at the beginning and come up with a plan. So
how the way you started this Mosaic is different from the way you worked on Nervana?
Yeah, at Nervana, it was, I think we actually had a clearer business model in a sense. It was really, at Nervana, it was like, I need to build a new piece of hardware for AI, right? The coming AI wave. And it was very technology forward because, we had to build this thing to enable all the new opportunities. That's a hard pitch, right? Because at that time, this is 2014, most investors didn't know what AI ML was. They didn't know what deep learning was. They didn't really understand why hardware mattered at all. And in fact, a lot of them were scarred from the mid 2000s, a lot of hardware investments going south. So we were working uphill there. With Mosaic, it was a bit different in that we started with a problem first, in a sense. The problem is that costs are going out of control, and it's a clear trend. So that didn't require a whole lot of convincing, right? And then we had a technology solution to it. So in some ways, that was the right way to do things. Is you start with the industry problem and you work your way back. I think at Nervana we happened to fall into that. Uh, Maybe because we inherently knew it just from our own perspective, or maybe it was luck, or maybe it was some combination. I don't know. But the market came to us in a big way at Nervana, and I think here we knew the problem was there already.
How did building teams, different companies, your own and others, uh, what did it teach you in terms of how to build the effective team for Mosaic today? What are the most important things in people? You mentioned one, which is other competence.
Yeah.
What are some others? What are important things or traits in culture?
Yeah. I mean, and this has nothing to do with experience or anything, by the way. I mean, some people, like a couple of people that we hired at the very beginning, actually at Mosaic, had no experience or very little, like 1 year. But what I saw was a passion for this. They have to care. You have to be irrational. If you're not irrational, you'll never get through the hard times. It's like falling in love, right? You have to have that. If you don't have it, you will not succeed. I mean, that's a certainty to me. And I actually look for that in founders that I invest in personally. I do a fair bit of angel investing. And it's like, I want to see that passion, right? You care about this problem like your own child. That's super important. And I think, some of the early folks we talked to or hired at Mosaic fall into that category. Of course, the competence part is super important, and or maybe one of the most important. But also thriving on risk, thriving on unknown. I think this is like almost a hardwired personality trait. I feel like for different people. I mean, ever since I was a kid, I sort of liked to take risk. It was fun, right? There's something thrilling about jumping into something I know nothing about, or like, jumping off a cliff and figuring out how to land, right? There's something thrilling about that. Some people find that absolutely horrible, and it's like not fun for them. They don't thrive under those conditions of high risk. And there's nothing wrong with that. We need people who are good at that too. But that's not a good fit for early stages of a startup, because everything is uncertain. You don't know what your market looks like. You don't know what your customers are. You don't know what your product looks like. You don't know if your technology is going to work. All of these things are unknown. And so you just have to have that sort of intrinsic drive to say, I'm going to go figure this out. I'm going to crack the nut. And it's almost never exactly what you lay out at the beginning. The customers you think you're going to go after may not be the ones that you actually go after. Like, all of these things happen, but you need to be able to navigate through and do those little micro pivots to make it all work. And that requires inherent motivation. It requires, risk taking and thriving under those conditions.
Passion, competence, and thriving on unknown.
Yeah.
Did you develop any approaches to how to probe for these qualities? How do you approach interviews with people?
Yeah, this is a hard one because the short answer is no. I don't think I have like one strict framework. It's more like it has to be a conversation. Um, for researchers, typically we will ask them to present something. I actually like this as just an interview question in general: is explain something to me. I don't care what it is. It can be basket weaving. Just explain something to me that you know a lot about, and convince me that it's important, and that I want to know more. Right? This is kind of important to communication. It's important to showing passion about something. If you're passionate about one thing, you're probably passionate about something else, right? So I think that's a good question. And so we did that a lot at the beginning, looking at what people have done, of course, and what their reasons for doing things are. That's also very important for me. Is if your reason is I want to make money, honestly, that's not a great reason. I mean, it's fine. There's nothing wrong with making money. I have nothing against that. But like, if that's your sole reason, you won't weather the hard times, right? That's not a good motivation, generally speaking. Maybe for some people it is, but it's generally not. You got to care about the technology, and I usually do that through a conversation. Then ask about what people do and for fun. Like, what are the kind of things that they have done throughout their life for fun. Did you go and build random systems that did cool stuff? Did you go and hack, into things for fun? Like, these are all actually positive qualities, I think, for early stage startup people, because it shows that they are just so inherently motivated to use technology to some end.
They're motivated to build.
Yeah, motivated to build. Absolutely.
And talking about the more, say, senior folks, execs, what's different there in terms of how you approach hiring them?
Yeah, I mean, I think founders, of course, are one thing. Then senior folks, like at Mosaic, we hired Julie Choi, who is a friend of mine, and someone who we built the whole Intel AI brand with together. I actually interviewed her at Nervana, but couldn't hire her because we were under acquisition process and we couldn't hire her. So we brought her into Intel when we were there. Um, she hits all these boxes. Someone I trust, very well, and so that was somebody that, to me, it was very easy to hire early because the trust was there. Later on, I wanted to see the need before we hire executives, right? I think a lot of people come in and they're like, "Oh, I need to check all these boxes." I don't do it like that. I want to see that, like, I can't do it right now, or my co-founder can't do it, or the other people on the team can't do it, and then we need somebody. It has to be motivated. And I kind of joke, like, your job as a founder is to be able to do everything in the company poorly. Because first you have to come in, you got to do payroll, you got to do hiring, you got to do all the stuff that someone does eventually, but you have to do it well enough to get it going, and then you kind of discover the need, and then what competence means for that becomes clear. And I think this is how we've gone about it. I think we ended up hiring several people that we knew early on. Also, this year, I don't know, 7 months ago or so, we hired a VP of engineering, Hagai Lepesco. Looking at him, great resume. Led ML teams at Meta and AWS. Also, just talking with him, he wants to build something new, and he has that background of competence, and he had this right attitude. So he's been a tremendous fit. And again, it just takes time to build that trust. And I would hire him in a heartbeat anywhere else, for instance. But I had to establish that early on. So I think these things kind of take time to build up and earn trust. Same thing happened now with a VP of sales, Barry Dauber. He came in through recommendations through my investors. I talked with a guy. It was just like instant perfect fit. We're like, all right, we got to bring this guy on. It was too early for us, actually, for sales. But in the end, it was a good decision, because all of a sudden we started selling a lot more. So ended up working out really, really well. But so the same kind of thing. It's a feeling. It's a gut feeling. It's also, attitude and need and all of that. So I think it's an inexact science, to be completely honest. And I hate saying it that way because everyone wants like these nice rules and frameworks, but there's all those rules and frameworks don't lead to much better outcomes, in my view.
Yeah, we definitely would want a process. If it's not rules, hard rules, then just the process that going through which you will definitely build the right intuition about the
Yes.
person. That would be the great thing. And I think for lots of first-time founders, it's really hard to figure out how to hire an first execs, especially because execs are good at presenting. They should
Yes.
be, otherwise they could have not been
That's right.
the execs. So what's your advice? I don't know. What do you say? What kind of pitfalls they should avoid? And maybe, I don't know, a couple of tricks to help them navigate this.
Yeah, I think trust is probably, if I had to pick one single thing, just get that gut feeling that you trust this person. It's very important. Again, you're going to be in the foxhole together. You've got to trust this person. If that's not there, nothing else works. Even all the competence in the world doesn't work. It's sort of, you don't want to end up in a place where you have a competent asshole or something like that, right? You want to trust this person. You want to like this person. These seem like, soft and fluffy things, but if that's not true, it's not going to end well. You have to trust and like this person. So I would say almost erring on the side of maybe you don't know everything in terms of how well this person's going to do in the specific role that you have contemplated, but if you trust and like them, you can usually make it work. That being said, of course, there's a certain bar of competence, right? I mean, this person's led teams before. They do care about the space. Like all of this stuff has to be true. I think that's kind of table stakes, but um, yeah, I think that serves a lot of people, and I've seen the opposite happen a lot. Like people would be like, oh, this person looks great because they have this great resume. They come on board and they didn't really assess the cultural fit, right? They don't think that person doesn't think about the world the same way they do. It becomes a lot of friction, and then that's going to end poorly, not just for you but also for your team, because if that person's a leader, um, they're going to affect the culture in negative ways. Firing them later is going to hurt the team. There's a lot of bad stuff that happens. So trying your best to not have to fire someone, it should be what you're really looking for. And I think it all starts with trust and likability.
You basically what you're saying is that you as a founder, you will have the right intuition about the person. Just make sure that that intuition isn't silenced by or overruled by the impressive resume.
That's right.
Or by the way they kind of present themselves.
Yeah, it's a funny thing. And this is something that's taken me a long time personally. Is learn to trust your gut. Sometimes I've learned to do that much more now. And sometimes, hey, I don't know why, but this person just doesn't feel right. We're just not going to move forward. I don't know why. I can't articulate it, but I don't want to do it. That's okay, right? It shouldn't be that, oh my God, I'm being irrational. Don't worry about it. Like sometimes that feeling is right, and you should go with it. And I think that's true for a lot of things. And I've learned over the years that my gut has actually like been right many times, and I should have just trusted it rather than trying to override it with logic.
Yeah, there is an idea that you should find a field of your work where your gut, where your instincts are good,
Yeah,
and stay with that field instead of trying to make it work in a field where your instinct doesn't serve you well. And
that's
I
right.
think that's a very good idea, very good advice.
Yeah, and your instincts are built from your experience, right? And I think you won't have good instincts if you're new to a field, right? You just won't, and that's okay. But after a while, like you do, right? You have a good sense of what's coming, even though the evidence is small, it's scant. And so that sometimes it can be the big differentiator. It allows you to say like, you know what, I'm going to commit to a direction. Okay, like that. Sometimes having that clarity of purpose for a company is better than being just a little bit wrong. If you're a little bit wrong, that's okay. You can fix that. But having the clarity of purpose, like this is what we're doing, is actually more important. So that comes down to trusting your gut and kind of being confident about those decisions.
What are your goals for Mosaic as a company long term?
Yeah, we want to be the place that allows everybody to access the state of the art of machine learning for every type of industry. I want to see generative modeling and all this kind of cool stuff coming out to be applied to healthcare, to be applied to pharmaceuticals, to precision farming, to finance, to everything that can improve human life. I want to see that through that we can actually create positive opportunities for people in places where humans are doing drudgery, and we can actually remove some of that drudgery. Those people can go and do other things. So I think there's a lot of opportunity here in terms of automating processes that humans kind of do today but don't necessarily want to, and making their experience of the world better. In the shorter term, that comes down to constantly making the state of the art machine learning more efficient over time, and bringing costs down. And I think that's something that's underlied the tech industry since day one, is that it rides on exponentials, right? Software gets exponentially faster. Moore's law makes exponentially more transistors on a chip. Like all of these things are how we make such tremendous progress in the tech world. And exponentials now in the AI world are incredible. 4x per year. That's huge, right?
Yeah, it is way faster than anything I think before
Yeah, it's
that
insane.
we saw. In terms of the near-term future, say 5-year horizon, how should the founders starting today think about this? You uh, wrote a tweet a few days ago that where you said basically that LLMs and generative AI are very important, but there are lots of places to make fundamental progress in AI/ML.
Yeah, I think there's a whole slew of product companies in various verticals, and I still think that's where there's a ton of opportunity. And now we're getting tools that make that technology um, easier to implement. So this reminds me very much of kind of the early days of internet. Right, at first it was very hard. You had to like stand up your own web server and all this kind of stuff. Then after a while, that got a lot easier. Scaling and doing failover became easier. That enabled people to start thinking about, oh, I can build a platform for this or a platform for that. And so I think companies like Jasper AI, where they're doing copy from copy editing from generative neural networks, is an example. We're seeing a lot of stuff with companies like Stability AI and Runway ML using diffusion models to do cleaning up videos or generating new images, generating slide decks, what have you, right? So there's going to be this thing where I generate stuff for various industries, and it's completely open and untapped right now. And the tools have gotten easy enough. You use us, you can build your own models to do whatever you want. You can even take an existing model and probably modify it and start testing the market. There's a lot you can do with very little. And I think this is where the next run of really big companies are going to come from in the vertical spaces. Um, I want to see a kind of a new development methodology emerge where previously computers were used as tools to test our hypotheses. I, as a human, say, I think, this kind of wing on a race car will give me more downforce. Okay, then I go build a simulation. I test that. I can use physics modeling and all this kind of stuff and test that hypothesis, refute it, or support it. Now we can use neural networks to generate hypotheses. So it almost becomes like a a collaborative kind of thing where I'm collaborating with the AI to actually come up with my testable hypotheses. That's pretty cool, and I think that's going to change the way we design everything. And I think there's so many opportunities to build products around that. I can't be prescriptive on those exact products because I don't know what they are, but I think this is the general area where we can aid humans in designing and building stuff, aid humans in writing about and transforming information for different types of consumption. These are the two big areas I see.
And a few days ago, we actually talked to a founder of a company called Neural Concept that does exactly what you said.
Cool.
They apply AI to design the parts of cars. They even used it to generate design for a bicycle that set a new record in human speed. What would you say are important things that founders starting a business applying AI today should consider? What are the pitfalls, or what are other important things they should understand or realize when starting an AI enabled company?
I think there's a couple of things. One is use tools where they exist. Don't have this not invented here attitude. I've seen too many companies do that, and it just costs you more money, and you're gonna fail. It's just very hard, right? Some of these tools are, not just us, but like the whole slew of tools that are out there. There are some really good tools now that you can use and move very fast. Use the tools that exist. Don't try to build everything. Also, that technology is not always your differentiator. It's what that technology enables, and I see a lot of people, and myself included. I'm a pretty hardcore geek on a lot of the technology things, and I love it. But in the end, markets don't care about technology; they care about what technology can do. What it can enable, what people want to pay for. And always keeping that in mind, that nobody cares about the technology like you do. That's fine. Always have the viewpoint that what will this do for my customer, for the markets, for investors, whatever, is a very productive way to frame things, rather than I'm the king because I have this technology. That's not gonna serve you in the long term.
Yeah, the way I say it to founders is, if in your 1 minute pitch you spend more than 5 seconds on AI, then you would be better off likely replacing those extra seconds with the value proposition for the customer.
That's exactly right.
Okay, and now talking about overall the long-term evolution of AI, what excites and concerns you most there? You had a conversation recently with Gary Marcus where you talked about how it's important to present the capabilities of the AI systems properly and make sure we realize their limitations.
Yeah.
So that's definitely one of the important things going forward as we apply AI broader and broader. So, what are the other concerns, but also what are the things that excite you about the field?
Yeah, in terms of concerns, I think that was specifically around autonomous driving, and there's a lot of places where you can literally kill people, right? And we need to be very thoughtful, and these kind of testing frameworks and stuff like that need to be very, very well thought through before we put things in a position to kill people. And even if the statistics are slightly better than what a human is, just like we talked about, people freak out when technology doesn't work perfectly. We freak out. So everyone can whine about that if they want, or just accept the fact that technology has a higher bar, and that's okay. It's the way it is. We expect things to be more perfect or closer to perfect when it's synthetic. So I think those are the kind of areas that do concern me when it comes to ethical stuff. Like when you start putting bots into the world on social media, their information blast radius is very big, right? Generation of false information is actually very easy now. False images, which as an expert, I can usually still tell if something's a false image. I don't think it's going to be true very much longer, right? Uh, so
Yeah, you have to look harder and harder every time
that's
to
right.
find those inconsistencies.
Exactly. They're like little tiny things. Sometimes it's just the way the background looks or something like that. But it's getting very, very hard. And data provenance is a big problem. And actually, I wish there were folks slightly outside the AI space who are working on tools for watermarking data provenance. Actually, this is one of the applications of blockchain I was hoping to see instead of all the ridiculous stuff that we have seen. Is that if we all agree on a blockchain and data is sort of like attached to that in some way, we can actually sort of prove provenance of data through blockchain. This needs to happen because data is no longer like a picture or text or whatever is not sufficient anymore. I mean, if you think about it, right? Like we take a picture on a camera and we say, okay, this is proof that this happened. It's only proof that it happened because it was difficult to make something fake, right? but it really is no proof. There is no good way to prove that unless you have some kind of logging of events that we trust. And I think this is an important area of innovation. Someone who cracks that, I think, will actually have something very meaningful into the world.
It's interesting that we went through the same thing with the text, as you mentioned. We don't trust random texts on the internet because there is no way to prove that it's a genuine, authentic text written by someone who, the text claims it's written by. So the truth is, over these years, we just figured, okay, we have the digital signature, so we can do that. We can authenticate. Or we have a trusted middleman. So if it's on Twitter and it's under your name and you didn't notify anyone that you got hacked, then probably we can assume that you wrote the thing that you wrote. So digital signature and trusted middleman. And yeah, you're right. I mean, blockchain hasn't lived up to that thing yet. but yeah, it still can.
It can, yeah. I mean, obviously the investments in those areas has decreased considerably over the last several months, but it will come back, and I think that actually is where it might have an impact in these sorts of problems. So, and there will be some interaction between AI and data and blockchain in this way. So I think that's very interesting to me. In terms of what's exciting about the future, it's really building these sort of synthetic intelligences that are capable of processing vast amounts of data, much more than any single human can process, is how we're going to make future scientific breakthroughs. And again, I'm a scientist. I'm a geek. I love science, and I love that humans can not only understand their own limitations, but then can build solutions that get around them. That's what makes us unique. And the biggest thing we have now is that science takes lots of data. It takes lots of collaboration. It's not something you can have like one super genius sitting in a corner, writing in his notebook anymore. It takes lots of people gathering lots of data and interpreting that data, and machine learning is the way to do that. And generative modeling is a way to actually come up with new directions of investigation. So there's something here that will change how we actually understand the world, and will literally change what we can build. So rockets that go faster than the speed of light or whatever. I mean, of course, we think it's impossible now, but maybe we just don't understand the science well enough, and this might be a way to get there.
This is definitely one of the most important contributions the AI can make.
Yeah.
Basically, powering our intelligence or boosting our intelligence,
Yeah.
Making the mix of our organic and synthetic intelligence more powerful than either.
Exactly.
Okay, sounds good. Where can listeners learn more about Mosaic? Where they can follow you on social media? Any other? I don't know if you guys hiring.
Yeah, we are definitely still hiring. We're our bar is very high, and we have a great culture. And if you want to change how and where ML is used, talk to us. We're hiring across DevOps, even customer program managers, researchers, software engineers across the board there. You can follow us on Twitter at Mosaic ML, or on LinkedIn, Mosaic ML. Or you can follow me on Twitter as well at Naveen G. Rao, Naveen Grao on Twitter. I'm also on LinkedIn as well, but I tend to share my thoughts about AI and ML on Twitter more readily.
Sounds good. We'll put all those links to the show notes.
Okay.
Naveen, thanks a lot for joining me today. It was a pleasure to talk to
Yeah,
you.
it was very nice talking with you as well. Thanks so much for having me.